Okay, so you are going to be going through and you're going to be learning about surface area. We are starting three-dimensional shapes. Now originally you were learning about two-dimensional shapes. So you were learning about circles, doing circumference and area. You were learning about angles. You were learning about composite figures. So that's what you were just talking about with me, but now we're moving into three-dimensional shapes. So surface area and volume. We are going to spend a few days on surface area. We're going to talk about surface area of prisms today, and tomorrow will be surface area of pyramids tomorrow. So those are the two that we're going to go through and be learning about. For surface area, starting off, does anybody even know what surface area is? Yes, ma'am.
Like, it's the, I know what it is, but it's the size of the shape that it was like multiply those and I'd be the area.
Okay, I know what you're saying. Elaborate.
It's the area of each side of a three-dimensional object, and you add them together to get a surface area.
So the surface area is the sum of all the surfaces or faces of a three-dimensional figure. Now here's the deal. That's super, super, super important. So the sum of all the surfaces or faces of a three-dimensional figure is going to be your surface area. If you ever see me do something like this, that is not an airport term. It is at the airport, but in math, it represents total surface area. Then you're going to see me do something at times that looks like this. That means lateral surface area. Lateral surface area is the sum of all of your faces except for your bases. So it does not include your bases. So lateral surface area is basically the sum of all of your faces except for the bases on your figure. And we're going to talk about what the bases are. So when you're going through, there will be times where I'm going to ask you for lateral surface area. There will be times where I ask you for the total surface area. Surface area is everything. Lateral is everything but the bases. Now there are a lot of things I need you to know about prisms, and I'm going to hit you with a ton of information with prisms. They're really important to know, and I'm not writing it all down because it's a lot to write down. Starting off, prisms. There are two bases for prisms. There are two bases for prisms. Every single prism has two bases. Every single prism has a rectangle as a lateral face. So it doesn't matter if you have an octagonal prism, a hexagonal prism, a triangular prism, a rectangular prism. Every single lateral face is going to be in the shape of a rectangle. And for the notes on Edmodo, I'll type this all up and put it in the notes page. So if you're like trying to remember all this and you have to see it, I'll have it typed up and put it on there for you for the notes on Edmodo. So I'm getting really cold with that fan. So the next thing, the shape of your base defines it. So if you have two bases, immediately I know it's going to be a prism, and expecting to ask these questions at the very beginning of class tomorrow. And then if you look at your base, that's going to define it. So what is the shape here? This is a triangle, so that means it is a triangular prism. If I have this, what is the shape of my base? A hexagonal prism. What about this one? Okay, here's the deal with rectangular prisms. If I ask you to find the total surface area, it does not matter what you decide the base is, because couldn't technically all of them be the bases? Technically, these could be your bases because they're rectangles. and all the other sides are rectangles, technically, you can decide which ones are the bases. If I ask for lateral surface area and you have a rectangular prism, I will specify what your bases are. So that way there's no guessing game. For, hold on. If you're trying to figure out how many lateral faces there are, just look at the base. How many sides are there on my base? 3. So that means there are 3 lateral faces. How many sides are on this one?
6.
So how many faces are there? It's lateral. 6. And they are all the same. Here's what you need to know about your bases. They are parallel to each other and they are congruent. They are parallel and they are congruent. So if I find the area of this base, that means that I know the area of this base. Correct? Trying to think. What else is there? This is my most commonly missed question. What is the name of the shape?
Rectangular prism.
What is the name of the base?
Rectangular. Wait, triangle?
If it is a triangular prism, what is the shape of my base? A triangle. Doesn't matter if I put it like this. Doesn't matter if I have it like this. If it's still a triangular prism, does the name change?
No.
No. If I am in this classroom, I'm still Mrs. Skinner. If I go downstairs to get something, aren't I still Mrs. Skinner? If, let's say, Alec goes to his next class, isn't he still Alec? No matter where Alec goes, regardless, isn't he still Alec? If, let's say, someone goes to bed, aren't they still the same person, regardless of what position they are laying in? Yeah, I am still the same person if I'm standing up or if I lay down. If I lay down on the floor, aren't I still the same person? So my triangular prism is still the same regardless of how you move it. A lot of times for triangular prism, my most commonly missed question with surface area is that triangular prisms will sometimes be shown to you like this, and I'll say name the shape of the base, and they'll say rectangle because it's sitting on the rectangle. Just because it's sitting on a rectangle doesn't mean that's the shape of my base. Does that make sense? So I'm telling you right now, this is my most commonly missed question. Now, for surface area, in 8th grade, like attacked me. In 8th grade, you will be given a formula. For me, how you're going to solve for surface area is the nets. So the nets are basically taking your 3-dimensional shape, flattening it out so that way you have it as a 2-dimensional. So you find the area of every single one, add it together, and you have your total surface area. If you know the formula, because I have some students who are like, oh no, I'm going to memorize the formula. That's fine, but just know that when STAR test day comes, you don't get that on your STAR chart. So that's why I'm not teaching it to you, because I will be doing you an in-service. Disservice? Disservice. I was like, that's right. Right? What is the shape? What is the shape? The shape. Wait.
This is the shape.
This is a net of a
Geometric figure.
Square.
It's a what?
Square.
It is a cube. So if you look, it is a cube because they are all a square. So if all of your sides, if every single face is a square, it is a cube. Think of a dice. So some of y'all were asking, okay, well, what's going on with this right here? That is just, if you were to take a net and put it together, those are just the flaps to help it stay together. With your rectangular prisms, we're going to do rectangular prisms first, then look at triangular prisms. You have a top and the bottom. If you can find the area of the top, immediately you know the area of the bottom. Then you have your then you have your front and your back. So if I find the area of the front, immediately I know the area of the back, because they're congruent. Then you have your 2 sides. Again, if you find the area of your side, you immediately know the area of the other side. Expect me to ask that over and over and over again, like non-stop, annoyingly, non-stop. So let's do this problem together. On this problem, we literally just talked about it, but raise your hand and tell me what are the 3 pairs of congruent faces that we literally just talked about, like 2 seconds ago. Just tell me one of them. Okay, I don't know if that's, okay, well you can go top and bottom. And we have front and back. And then, yes ma'am. Yeah, your 2 sides. So we're going to go through and we are going to do this. We are going to first find the area of our top and bottom. So here you have your top and you have the bottom. How do you find the area of the top? What are you multiplying together?
5.
Right, you have 4 times 5, which gives me 20. What am I going to do with this 20?
Put it on the bottom.
Yeah.
But what will I do with the 20?
You add
Multiply by 2. So you have 40. Then I'm going to go through, you have your front and your back. So let's just look at the back right here.
5 and 3.
Yeah, 5 times 3. So that means that the area of your front and your back added together is going to give you a total of 30 centimeters squared. Then you have your 2 sides.
12.
12. Okay, questions on anything I've done so far? Questions on anything I've done? Straightforward? You see it? Awesome. What is the next thing you think I'm going to add? Add them all up. So
94.
40 plus 30 plus 24. When I add all of those up, I get 94
centimeters squared.
centimeters squared. Remember, surface area. Area means your units are going to be squared. That really hurt. I can't put on this. So it actually started bleeding. So the surface area is going to be 94 centimeters squared. Questions? Yes, sir. You mean the top and bottom?
Yeah, how do I know which one's the base?
Well, on here, remember this one, I didn't specify which one's the base. If you wanted to, you could have just said that the top and bottom were your bases. You could have said your 2 sides were your bases. You could have said your front and your back were the bases. Unless I specify, hey, these are your bases, then in a rectangular prism, you can just decide. Here I'm finding the total surface area, so it doesn't matter what the bases are really.
Yeah.
Doesn't really matter because I didn't ask for lateral. The only time it really comes to play is with lateral surface area. Lateral surface area is where I don't include the bases. Do you see that thought process?
Yeah, I was just wondering if there was possibly a question where I was supposed to find the base from this information.
No, from this. No. So now we're going to look at our what is this figure? That's not what I told you. So this is a triangular prism. How many faces are there?
4,
5. Okay, we're gonna do a little trivia really quick. If I have a hexagonal prism, what is the total amount of faces? 8. 6 laterals and then your 2 bases. How many total faces are there in an octagonal prism? 10. Why?
Because 8 bases and the 2 things.
2 bases and 8 lateral. Triangular prism, how many faces are there? 5. Why?
Because
3 laterals and 2 bases. With your rectangular prism and your rectangular and triangular prism, actually all of them, but specifically triangular, your laterals may not always be the same size. Here, are they the same size? No, they're not all the same size. Sometimes, we're not there yet. Sometimes they will all be the same size though. So please be mindful of that sometimes you may not always have the same size for your laterals, but you know that without a doubt what's going to be the same. Yeah, your faces. So let's go through and let's do your faces. Here's our faces. We know to find the area of a triangle, what do I do?
Base times height divided by 2.
Okay, so you have 4
Times 3.
times 3 divided by 2, so that means that this is
12. 6.
6, so that means this is 6, so that means 6 times 2 is 12. Questions on the bases? Okay, let's find the area of this one. 3 times 4 is 12. Find the area of this one. What is it? Do y'all see why? It's 3 times 3.
Yeah.
3, and this is 3. So this right here is 3 because it shows me right here.
And plus it's a square.
Well, it is, but we didn't know that to begin with. And then here you have 5 times 3, which is 15. I know that this is 3 because right there. So what do I do? Okay, pause. I want my lateral surface area.
Minus the base.
Minus your bases, so what am I adding together?
12.
So what is that going to be?
36.
Almost.
Centimeters squared.
Thank you. And then total surface area?
Yeah.
38
Centimeters squared.
centimeters squared because you're doing 36 plus 12. Why 36? Because we found our lateral surface area. So lateral, 36 centimeters squared, total, 48 centimeters squared. Yes, ma'am.
Why is it 3 times?
Right here. Because this is 3 and this is 3. Do you see that? Because if this is 3, that means that the whole height is 3 all the way across. Yes, ma'am. Talk up. Sometimes you are not going to be given the net. Sometimes you are not going to be given the net. I'm going to show you how you can do it without the net, but it is not ideal. But I am still going to show you because some people ask. So on here, I have a box that's 6 by 9 by 2. How many square inches of wrapping paper would it take to gift wrap this box? Am I looking for total or lateral? I'm looking for total. So I am not an artist, obviously. So I am going, well, I'll still show you because if you're struggling with it. Someone's like, this looks like a cube. It's not supposed to, but whatever. Does it specify where your dimensions are supposed to go? No, so I just am randomly deciding. That looks beautiful. What are my 3 congruent sides?
Not in bottom.
Your top and bottom. Hold on. Top and bottom. Your front and back. And then your sides. You know how much I love to color code, correct?
No, I haven't learned.
You have not learned that yet. Oh no. You do not know me. So, you have your top and bottom. So if I look at this, I just color coded my top and bottom. What is going to be the area of my bottom?
36. 54.
Yeah. 6 times 9 gives me 54. What do I do to find the
Times 2.
times 2, which gives me 108.
I added that. I can't multiply.
Oh, just don't tell me that. Then I'm going to go through and I'm going to find the the front and back. Now here's the deal. For the front, it's going to get really hard for me really fast if I go through and shade the front because it's just going to look like a blob of crayon. So I'm just going to shade the back. So on here, what?
I was doing that.
Okay. So on here, what is the area of my back?
Well,
Because if this is 6, then that means that this is 6. So 6 times 2 is
12 times 2.
times 2 with
4.
24. So that's the area of one of the faces. So what do I do? It's 48. And then, wait, what?
You say?
Purple.
Oh,
Because 6 times 2 is 12.
and then 12
Times 2 is,
So why did you do it again?
because 6 times 2 is the area of your back.
Yeah, you already found it.
And that's 12. So then, to find it.
Because 6 times 2 is 12.
Oh, thank you. Thank you.
You did 12 times 2.
6 times 2 is 12. Times 2 is 24. Yes.
Yeah, you did.
Good catch. And then you have your sides.
9 and 2, 18.
Purple.
Purple.
Oh, purple's better than yellow.
Yes.
Trust me, I did yellow earlier and it like killed all of our eyes, so we had to change it. Lesson learned. You weren't in here. So you have your two sides. How do you find the area of one of your sides?
9 times 2 is 18. 18 times 2
36.
36. I would keep it.
9 times 2 is 18. Times 2 is 36. Questions? So here, if I ask for your total surface area, what do I do? So you do 108 plus 24 plus 36. What do I get?
132 plus 1. No, you get 132, so you add 36. So then 168.
Everybody find it.
168.
Okay? 168. Is it inches? Inches squared. Question. Are y'all getting it? Is it pretty straightforward?
Yeah.
Okay. On here, we're going to do the net. I'm going to show you. So I showed you this example where you can just draw it because I know everybody's brains work differently. My brain sometimes some problems works like this. Other problems, I have to draw the net. So here to draw the net, I know that this is a what? No, that is not a rectangular prism. Triangular, little part of me. So, triangular prism, I know because my bases are what? Triangles. So I'm going to want my lateral surface area, and then I want my total surface area. Let's go through and look at this. I am going to... What? Here are my laterals, and then here's my triangles. So I know that because here is this. Now, some people are going to ask me, how do I know what to label? How do I know how to label it? Let's go through and let's look at this. I know that my base of my triangle is what? 4. So that means that this right here is 4. The height of my triangle is what? 4. So that means that this right here is 4. And then, you what? So 4 is pointing to the height of your triangle. So then I know that it shows me right here is 11. So that means that this is what? 11. Are all these the same?
Yes.
They're all the same. So I can go through and say this is 4. What is this? 4. So what do I do with my laterals? This is going to be, which is
44 times 3.
So 44. So you have 44 times 3. What does that give me? Do it then.
124.
What does it give you?
132.
Y'all agree?
No, wait. Negative squared.
What?
Negative.
So I'm 32. So, do I know my lateral surface area?
Yes.
So 132
Meters squared.
Any questions so far? Good? Good? Okay. Some of y'all are giving me a look.
Like one thing I looked up. This one's easy.
And then here, what are the
Force. And that's
no, what is the title?
6.
Faces. So if this is 4 and this is 4, what is it?
16. So you multiply 15, you get 32.
How do you find the area of a triangle?
8 times 2. 16. I know. It's like 16, okay. 8. 16 times 2.
So this is 8 times so this is
68.
So 16 equals my bases. What is going to be my total surface area? What I do?
148.
Oh no.
That's my one. So what is my total?
148.
What is it?
148.
Meters squared. Okay, 5, 4, 3. Thank you. So how did you find 148?
Add all of them.
Raise your hand if you have a question over rectangular prisms. How I found it.
You mean triangular?
Nope. Rectangular prisms.
What?
Raise your hand if you have a question on how I found the surface area for a rectangular prism. Which are these? Raise your hand if you have a question on how I do triangular prisms. Yes, ma'am.
If there's like the triangle on the side, you just find the area and then add it to like.
For the total surface area, you find the area of everything. But remember, if you find the area of one base, you multiply by 2 because they're parallel and congruent. Any other questions? Yes, ma'am. All bases are congruent. So here, that means if I find the area of this triangle is exact same as this one. If I find the area, and you're not going to have to worry about finding the area of these, but I just want you to know. If you find the area of, what is this? So if I find the area of this, then I have the area of
What is like a
hexagonal prism. Hexagonal prism. Okay,